So we were talking about chemical reactions and how it changes the bonding between atoms. Sometimes we have changes in the nucleus of an atom, and this is what is referred to as the formation of isotopes. So isotopes are different forms of a particular type of atom. So a good example of this is in carbon. Carbon actually exists in two forms. So we call this carbon 14 versus carbon 12, okay? And so if I look at this, this means that there are a different number of neutrons in the carbon. So this, for example, would have 8 neutrons, and this one would only have 6. So carbon 14 and carbon 12 are examples of isotopes. So they have the same number of protons and different number of neutrons. Okay, so carbon 14, carbon always has 6 protons, and so carbon 14 would have 8 neutrons and 6 protons, and carbon 12 would have 6 protons and 6 neutrons. Now, why is this important? This is important because in many cases, there is a more stable form of an atom. And in its unstable form, sometimes the atom will emit energy and become radioactive. So radioactive isotopes are unstable. Unstable versions of an atom. And you might have heard of carbon dating. So as when we're alive, we're incorporating carbon 14 into our tissues. And then as soon as we die, we stop incorporating carbon 14, and carbon 14 will slowly start to become carbon 12. And that ratio, if I were to look at, say, I found some bones that were from like, I don't know, 6,000 years ago, I would look at the ratio of the carbon 14 to the carbon 12, and that would allow me to date it. Carbon dating does not go back really long, however. So it is not useful if we're looking at organisms or fossils that are like millions of years old. So these radioactive isotopes are interesting because they also emit energy. So we do have radioactive isotopes that we use, and there are some that are actually normally found in nature. So for example, uranium 235 and uranium 238. So we have radioactive uranium. So an example would be radioactive uranium. Okay, so if we were to find some of that radioactive uranium and use it, we might be able to use it to produce energy. We might be able to harness that energy that is being released by it. And that is the basis for nuclear reactors and the production of energy. We could also use it as weaponry. So for example, they use radioactive uranium sometimes in ammunition in order to, the ammunition is going to be radioactive. So if it gets into your body, it is going to cause sickness because that energy is going to help, it's going to start to break down the DNA and the proteins in your body. So radioactivity, it can be very, very dangerous, right? And the people like Madame Curie who discovered radioactivity didn't live very long because they died of radioactive poisoning, but also of cancer because of the mutations that were caused by the radioactivity that they handled on an everyday basis. Okay. Another good example of this is in in the past, people were using radioactive elements to create dyes or fluorescence. So for example, when we look at the painting of clock dials so that they actually glow in the dark, that would be due to a radioactive element that was in the paint. And that caused all sorts of problems in the people that were applying the paint to the clock dials, for example.